I'm Cheryl Porter. I'm co-lead of the AgMIP IT team. Most of you have met me, I think. And today I'm going to be presenting the AgMIP data protocols, particularly as they apply to phase 2 of the DFID project. So what I want to accomplish during this webinar is first to provide guidelines and rules for keeping track of the AgMIP Regional Integrated Assessment data and files for all of the teams, and to define the metadata requirements as we go into phase 2, how we keep all of our modeling processes together using the metadata. We want to review data archiving requirements, and these apply to everybody in the teams, from the climate to the crop and livestock modelers to the economic modelers and on into the stakeholder assessment group. And then the second half of the webinar will be moving into topics that are relevant for the crop modelers. So the agenda is to cover the data protocols for everyone, the metadata standards, archiving AgMIP data, and a little bit about the data journal. And then at that point, if you are not interested in the crop modeling protocols, feel free to drop off the call, and we'll go into topics that are specific just to the crop modelers, which will include the crop model simulation sets for phase 2, which are a little bit different than for phase 1, a simulation roadmap, and the updated AgMIP tools for crop modeling. Okay, so why do we care about data provenance in the regional integrated assessment process? First of all, a little bit about data provenance. That's going to allow us to, at the end of the process, for the information we present to stakeholders, it will allow us to know the history of those data that we are presenting to stakeholders. So we know exactly what climate sets were used in the analyses, what crop models, what assumptions were made. So it gives us a history of this final information that's presented to stakeholders. So it allows all of the modeling processes to be cohesive. It pulls everything together. It allows our final analyses to be transparent. It tells us exactly what went into the analysis to produce these final results. It allows us to reproduce the analyses based on the metadata from the final data. We can go back, find the information that was used to produce those outputs, and reproduce it ultimately. And finally, it allows what the analyses mean. Okay, so what are these metadata? We got together with the leadership for climate, crop, and economic analyses and put together just these 7 simple variables that will allow us to identify any simulation set, from climate to crop to econ and all the way to stakeholder assessment. So what are these? These are the, first of all, we want to identify the region, and we want to use the same regional identification all the way through, from climate to crop modeling to econ to the final stakeholder tools. The climate scenario identifier, that's the climate ID. We want to know the stratum. Okay, for many of the analyses, you'll be dividing your populations into strata, either by geographic area or socioeconomic status or other kinds of divisions. We need to identify the RAP that was applied in any analysis. We need to identify the adaptation packages using the management ID. We need to identify which crop or livestock or aquaculture production is being analyzed. And finally, particularly for the economic analysis, we need to know which core question is being answered. Okay, so a little bit more about each one of these. Okay, the regional identifier. This is really important that we carry this through all the way through the analyses and that we use the same identifier all the way through. But it can be a little tricky to give a regional identifier. First of all, you want it to be short. You want it to identify the region, and it needs to be unique. So, you know, we threw around having some kind of registry that we identify these, and ultimately maybe we'll do that, but I think that using a set of rules, you can come up with something that is bound to be unique for your region. For instance, if the region lies entirely within one country, you can use the ISO 3-character country code to identify part of it, and then you can use some other identifier, a sub-country description. For example, the first example I give here is PAK, 3-character country code for Pakistan, and Underbar, and then Punjab would be the sub-region within the country. Another example could be where you have, for instance, Lake Victoria. If you were studying that region, it encompasses several different countries, and so in that case, the ISO 3-character country code would not be relevant, but you could identify it as the Lake Victoria region. So there's no one way to do this. Each team is going to have to identify what is the best thing to identify their particular region. Okay, so the second metadata element would be the climate scenario identifier. We've already been using these in phase 1 pretty strictly because the climate team came up with a set of codes that identify each particular climate. It's a 4-character code. Those have been codified, and I think our teams are already familiar with these. The trick now is to use them throughout the analyses and make sure that these carry through all the way to the economic analyses and the stakeholder tools. Okay, so the third one is the stratum, and this defines elements of the regional or socioeconomic strata. This can be done in different ways. So it might be a socioeconomic. I've got an example here of rich farm, so you might have rich farm, poor farm, or some other way, you know, that livestock owners or non-livestock owners. Or it could be done geographically, where you've taken your region and subdivided it based on some geographical features. Okay, so we also want to identify the wrap that was used throughout these. This is important in phase 2. This becomes important in the crop model and livestock models, because we will actually be modeling some elements of the wrap with our crop models. So it might be as simple as R1 for wrap 1, or whatever you want to call it, as long as the teams identify that and use it consistently throughout. Similarly, we have a management identifier. This will be used for the climate change adaptation packages, and again, these will be used in the crop and livestock models and carried through to the economic models. We've got the crop identification. So the ACASA crop codes are listed. They've been codified already. We've got 3-character codes that identify each of the crops. We haven't done that for the livestock or aquaculture production yet, and that's something that we really need to codify with the livestock modelers. So we'll be looking for that in phase 2, such that just so we have this consistency as we move through the different modeling components.
Carol, this is Ken. Can I jump in with a question on your wrap and management identifier?
Yes.
Once someone names it R1, it needs to stay that way all the way through, and you can't name something else R1.
That's correct. So you can have an R1A or an R2, but yes, we need to have consistency for that particular.
Otherwise, you need to look inside the dome to see what you did, which I guess you could explore. But okay.
Okay, and actually, Roberto has put in a comment for the wrap identifier. It needs to be a 2-digit ID, where the first digit would identify the SSP that the wrap is based on, and the second digit would be the wrap used in that region. So the ID would be 2.1, meaning SSP2 and wrap 1. Okay, so that's something that I was not aware of before. there already is a method for identifying your wraps. So what the teams need to do is, with the economic modelers, working with the crop modelers, identify what that is and use it consistently. Okay, that's good. Thanks, Roberto. Okay, so we've got the wrap ID, the management ID to identify wraps and adaptation. We've got the crop codes coming up with livestock codes in phase 2. And then the last piece of metadata would be the core question. For phase 1, we had 3 core questions. And for phase 2, we now have 4 core questions. So we've decided that what we need to do is also identify whether it's phase 1 or phase 2. So for phase 2, you would put P2 Q4 to identify question 4 in phase 2. Similarly, phase 1 might have a P1 Q3. Okay. So within the climate data, we've already identified the .AgMIP files. The climate ID is already specified in the name of that climate file. The region and strata may become important within the climate teams, and those can be listed in the title. But they are attached, regardless of whether they're in the .AgMIP file. The region and strata become linked to climate data when the biophysical models are run. So it's identified in the domes of the crop modeling data sets, and so the climate data become linked when the crop models are run. Okay, so I'll show examples of that in the crop modeling set in the second half of this session. And in the economic model, there are some revisions being done to TOA-MD that'll be used in phase 2. And now these metadata will be explicitly identified in the TOA-MD input and output files. Okay, so along with that, we've got some crop model file naming rules, which you've probably seen before. These were in the protocols for phase 1. But this will help use these metadata in your file naming, which will help you keep track of what files are used for which analyses. Same for the TOA file naming rules. These also came from phase 1, where the metadata are used in the file names explicitly. Just a suggestion here not to use hyphens in the metadata names, because in these file naming conventions, we use hyphens to parse out different elements of the metadata. So hyphens in your actual region name or wrap name would be a bad idea. Okay, archiving data. This is also directly out of phase 1. These are the data that we expect to have archived for phase 2. It hasn't changed. For climate, we've got the observed weather data, the daily climate data, and we've got the feature ensembles. What's different here is that we're archiving them in ACE-B format. This will go into the crop site database with the crop modeling data. Okay, so it will be archived in our standardized, harmonized AgMIP format, the ACE format. The sensitivity analyses will also put those in the crop site database in ACMO files. We've got the standard crop modeling data. We want the calibration data, the calibrated cultivar parameters, the harmonized data with the farm survey sites, all the domes, crop model outputs. And economic data, we want the TOA inputs and outputs and the dev wrap. Same as in phase 1. The difference here is that we are also developing a separate database for use for the economic data. These will be linked through the metadata to the crop modeling data and the climate data. Okay, so a little bit about restricted data. These are the data that you do not or cannot have released. So all data on the AgMIP data interchange are open under the Creative Commons Attribution License. So if you have data which are restricted, that is private and not to be distributed, we need documentation of that so that we do not store the data. We do not want to store your restricted data at all. Okay? What we can do is we can temporarily protect the data, which will ultimately be released after you publish. Okay, so there's kind of 3 levels of data here. One is completely open. One is restricted data that will never be allowed to be published on our site. And the third is this protected data, which is temporarily protected and will become open. Okay, a little bit about the AgMIP Impacts Explorer. The Impacts Explorer is to be developed as part of Phase 2. This is one method of providing your research results to your stakeholders. The regional research teams are expected to contribute to the development of the Impacts Explorer in that we want you to review and comment on the prototype user interfaces such that we can prepare what's needed for the stakeholders. And the teams are required to supply data from your analyses in the proper format for use in the Impacts Explorer. Okay, so those are the data types that I just covered. Okay, and the Open Data Journal. This has been discussed before. This is actually operational now. We've got the first data set that's been submitted to the Open Data Journal. This is a means for you to publish high-quality, peer-reviewed data sets for permanent archive, retrieval, and reuse by the agricultural research community. Okay, so it operates like a journal. Okay, you're submitting data sets. They've been annotated. They've been documented. They're submitted to a review panel. The journal has editors, it has reviewers, and it has issues that come out periodically. Okay, so this is an opportunity to get your data published and get credit for it. It's a little different than the AgMIP crop site database in that that is all harmonized data. It's not necessarily meant for human retrieval. It's meant for machine retrieval and translation. This is actually meant for people to download your data and look at it and possibly use it in further analyses. Okay, so there's a website at the bottom, odjar.org, if you want more information. Okay, and the last thing, this is the last slide in the part 1 of this webinar, and I just wanted to mention FACEIT. It's developed originally or mainly for the crop modeling analyses. This allows us to string together applications in a workflow setting. The workflows are then run in a cloud-based computing system on the Amazon EC2 cloud. And it's also got some visualization tools that allow you to try to make sense of the outputs. We've also developed, or in the process of developing, some climate tools for use within FACEIT. So this is of interest not just to the crop modelers, but also to the climate modelers. We'll have a couple sessions in Victoria Falls on using FACEIT. So be prepared to work with FACEIT with your data in Victoria Falls. Okay, so that is all that I wanted to cover in part 1. So if there are any questions now on what I've covered so far, please go ahead and put them in the chat, or go ahead and unmute yourself and you can ask. Is there a question? Okay, I'm not hearing any questions. I do hear a little bit of noise. But if there's no questions, I'll move along to part 2 of the webinar, which has to do with the crop modelers. Okay, I see a question from Bright. I applied to join the FACEIT group but have still not received confirmation. Okay, so please send me an email if you're having trouble joining the FACEIT group, and I'll make sure that you get added. Any other questions on part 1 before I move into part 2 on crop modeling? Okay, so there's an economist that asks the question, I'm new to AgMIP team and some of the terms seem strange to me. Okay, yes, we have
Cheryl,
on the website, I don't remember the location, but we do have a glossary of terms. So I'm sorry if I used a lot of acronyms. RRT is Regional Research Team. RIA is Regional Integrated Assessment. We need to have a short session on an overview of AgMIP possibly for the new, for the people that are joining new. That maybe one of the leaders knows a little bit more about whether we will do that in the workshop or not. Okay, Justina, thanks for your comment. We will take that into consideration and try to bring you up to speed in Victoria Falls. Okay, very good. I'm going to move along to part 2. Anybody is welcome to stay on the line for this, but again, it is mainly geared towards the crop modelers.
Cheryl, I see a question from
Okay.
Sala. Did you see that one? There was another question there.
Okay.
I have recently changed my laptop and QuadUI is not working.
Okay. Yes. Again, Bright. Please send me an email to cporter@ufl.edu, and we'll try to take care of whatever problem it is that you're having. Okay, so I'm going to move along to the crop modeling methods. There's a lot of material here to cover. I'm going to move very quickly. A lot of it is review of phase 1. Okay, so I'm not going to spend a lot of time on that, although I will show some slides that review phase 1. So for phase 2, you've seen this before. Ken Booty covered it in his webinar last week, but now we've got 4 core questions that we're covering. What is the sensitivity of current agricultural production systems to climate change? What is the effective adaptation applied in the current climate? What is the impact of climate change on future agricultural production systems? And with climate change. So in order to answer these questions, we have 2 climate systems, the current climate system, and we have the climate change systems. Climate change, we're looking at 5 GCMs at each farm site, and for a particular farm site, we'll look at the full range of 20 GCMs. All of these for mid-century RCP 8.5. Okay, so we have, these are the simulation data sets that we'll be looking at in phase 2. There are 6 simulation data sets using different combinations of current climate, climate change, current production system, a future production system modeled with a RAP, and a future production system modeled with an adaptation. Okay, so what's different here is that we're actually taking components of the RAP, which are developed with the stakeholders and the economists, and we're modeling components of these. So Ken Booty covered these last week. I know there's probably still some questions about how that's done and what's different between the RAPs and the adaptations. A lot of that will be covered in the workshop in Victoria Falls. I also want to point out that we actually have a 6th simulation data set which models the historical simulation. This is the modeling exactly the conditions that were surveyed for the year that was surveyed. So this is needed for the model validation, the construction of the field overlay data. This is the only simulation for which your simulated versus observed is relevant. Okay, so you may actually spend the most time building this simulation data set and getting it correct. Once you've got that simulation running, all of the others build upon that. Okay, and in addition to those simulation data sets, we also are asking for some sensitivity analyses. These are the CTWN and C3MP analyses. These are for comparison of the crop model responses between that and AppSim or other crop models that you're running. This is done for one farm site only. Okay, so you're going to take your phase 1 data, pick a representative farm site, and do these sensitivity analyses, varying CO2, temperature, rainfall, and fertilizer nitrogen. And then also the standard C3MP, the 99 sensitivity analyses done for a C3MP analysis. We've developed some IT tools. We've added a batch dome. This is a new kind of dome which allows us to take one simulation set and then loop through, changing one or more things at a time. Okay, so this is going to allow us to easily do these sensitivity analyses with very Okay, so a review of the data types used in a regional integrated assessment analysis. First of all, we've got the survey data. Everybody's familiar with the field data, the soils data, the management that goes there. Something that's new in phase 2 is that we're pulling out the weather data from the survey data. And the reason is that we want to reuse that survey data over and over and over again with different weather data sets, with the different climate scenarios. So we've pulled out the weather data. It's now supplemental data. We've also added cultivar data. So these are the cultivar files in the model-specific formats. These are your calibrated cultivar files. These are added to QuadUI and just passed through intact, no translation at all, but they're passed through to your data directories, and they will also be archived with the data for reproducibility. Okay, and then we get into the domes. Field overlay dome, you're familiar with. It's used to fill in missing data. Seasonal strategy dome is used to generate multi-year simulations from the survey data using planting date rules. The rotational analysis, this is something that we're working on now. This will allow us to do long-term continuous simulations for sustainability type studies. We've already got the ability to input these types of data, but the translators have not been developed yet to handle those data and turn them into simulations for both DSAT and AppSim. And we're introducing a new type of dome, that's the batch dome, which allows repeated looped simulations, which can be used for the climate scenarios and also for the sensitivity analyses. Something else that's new is a linkage file. This allows us to link the survey data with the domes. So previously in phase 1, we had this linkage in the survey data. So you needed to replicate your survey data for each analysis. Now what we've done is we've removed that linkage to a separate file. which allows you to use your survey data intact, no modifications, over and over again, just by supplying new linkage files and new DOMs. And finally, we've got the AgMO files, which is the AgMIP crop model output. Okay, so the tools we use are available in the AgMIP toolshed at tools.agmip.org. And these are the same as phase one. We've got QuadUI, which allows us to translate our data from raw data to ACE format. It applies any DOM data that we supply, and it translates from ACE format to crop model format. Ada converts the Excel spreadsheets to zipped CSV format so you can input it to QuadUI. And AgMO converts the simulated outputs to the AgMO format. Okay, a little review of the DOMs. The field overlay fills in missing data prior to the data translation so that all models use the same assumptions. So in the little graphic to the right, you can see that the ACE data, that's your survey data, is combined with the DOM data, and that combined data stream is then translated to our various crop model formats. The seasonal strategy DOM allows us to take a single year that was surveyed and turn it into multiple years for our weather variability analyses. It allows us to put in planting date rules, specify a climate scenario and a CO2 concentration. And you can use either the field overlay or a seasonal strategy to overlay a management regimen for applying wraps and adaptation packages. Okay, so the new type of DOM is the batch DOM. Allows us to do the climate scenarios. So we can use the same inputs, same survey data, same field overlay, and analyze it with multiple climate scenarios. Similarly, a sensitivity analysis can be done using a batch DOM by modifying one or more input parameters in a series of simulations. And I'll show you a little bit more what those files look like. We'll have some standard batch DOMs that we can use for your C3MP and for your CTWN sensitivity analyses. Okay, so the DOMs, it's a pretty powerful tool that you can use in different ways. So that we have various functions that have been developed that allow you to synthesize data, put in model assumptions, which have not been measured in the field, but that you need to supply to the crop models. Okay, so these are documented on the research site, research.agmip.org. You can just type in DOM in the search engine and it'll bring up this page. And you can see the documentation, the inputs, the syntax, and everything needed for these various DOMs. We also have DOM templates, okay? So all of these functions, we've put in some sample DOM templates that you can use and just put in your particular data relevant to your soils and your site and so on, relevant to your wraps and adaptations. Okay, so now we get into the crop simulation methodology. I've separated this into 4 parts. Part 1 being the simulation of historical conditions. That's the crop model simulation set 0 that I had on that one slide. This is to simulate conditions which were surveyed, and it's typically just for 1 year, whatever was surveyed. Part 2 is to take what you developed in part 1 and then turn it into a multi-year simulation. This is your current climate, current production system that we call crop simulation set 1. Part 3 would be to analyze these hypothetical scenarios. This is a CM2 through CM6. And then part 4 would be the sensitivity analyses, which is 1 farm only, and it's done to understand the model responses for your multiple models. Okay, so part 1, this is the survey data historical simulations. This is not very different from what you did in phase 1. You're going to gather your survey data, you're going to put it into the spreadsheets, make sure that the units are in the correct units based on the ICASA data standards. You're going to add the weather file either as .agmip or in CSV formats. You apply the field assumptions using a field overlay DOM. One of the things that's different here is you use a linkage file to show the connection between each survey site and the corresponding DOM that will be applied. Save all the files in CSV format using the ADA utility. And then you're ready for QuadUI to actually translate the data to crop model formats. You run the models for your historical conditions. View any error and log reports to see if the simulations were successful or not. Use AgMIP to combine the output data with the metadata. And run the analyses for model validation using the simulated and observed yield data. So this process is most of what you have to do when you're working with a new data set. This is an iterative process. There are many ways to get it wrong. Nobody ever gets it right the first time. So, well, I've got some more slides that go through each one of these steps that'll give a little bit more detail. So first of all, using a spreadsheet to convert the units to AgMIP formats. You're familiar with this process already. The ICASA labels are shown in line 18 of this particular example. Okay, these have very specific units associated with them and very specific definitions based on the ICASA standards. Each farm is identified with this EX name, so there's one line of data per farm site. In this particular example, we show latitude and longitude, a reference to a weather station ID, reference to a soil ID. It has a planting date. It tells us which crop is grown, the total amount of nitrogen that was applied over the season, the total amount of organic matter that was applied over the season, the harvest date, the amount harvested, and it has a place for some notes. So it's very minimal data that was collected in this particular survey. If your survey data has different information, you would have to go back to the ICASA master variable list, which you can get from this URL, and you would add new columns based on the data that you actually have. We have various different templates for survey data that are available from the research site, so you may want to look through those to see if one of those conforms to your data, or you may want to go back to the ICASA list to add your particular column headers. So I will say that the ICASA list is a living document. We update it, we change it based on new models that are added, new data that people have specified that they have that we need to add to the list. It doesn't happen often because it is a very comprehensive list already, but it is possible that there are additions or changes to this list. Okay. Field overlay DOM. Again, if you were part of phase 1, you're familiar with this, but this just shows a piece of a field overlay DOM that was used in an analysis. This one takes the total amount of nitrogen that was applied over the year and splits it into 2 applications. There's some more data off to the right that it doesn't show, but there's a function that'll do that fertilizer distribution. We have the same type of thing for matter application. Here's one that fills in soil organic matter, which was not part of the soil survey data, but it distributes it over the soil profile using a root distribution function. And there are a lot of other DOM functions that can be used in these field overlays. Okay, so this is something new in phase 2. We've got a linkage file. So this is this takes each one of the experiment names, or these are the farm site IDs, and for each one you can have one or more field overlays, and it can be associated with a seasonal strategy or not. If it's a historical, the seasonal strategy column would be blank, and the field overlay would be filled in. Okay, so this is exact. Is there a question? I'm not able to understand if you're asking a question, so please type it into the chat. Okay, so this information was supplied in phase 1 in the survey data. What we've done now in phase 2 is we've pulled it out into a separate file called the linkage file. Okay, step 5, same as what you did in phase 1. You save your information from the Excel spreadsheets to CSV files that are zipped. We've got this little utility called Ada that allows that to be done easily. There is a danger if you open a CSV file that the date formats, if you open it with Excel, Excel has a tendency to change the date formats away from the AgMIP and to whatever your system calls for, so be careful. Here's what QuadUI looks like. For phase 2, it's a little bit different. We've got some more areas to put in your data. You can see that the survey data up at the top, same as before, we now have a separate area to input your weather data. We also have an area to input your cultivar data. There is an option to enter your soils data. Typically, you're going to have that with your survey data, but it's possible if you use modified soil to, for instance, have a drought, to mimic a drought-tolerant cultivar, that for one of your adaptations, you may want to add soil data as supplemental data. DOME data are entered below that, raw data, field overlay, and seasonal strategy. This QuadUI does not yet show the batch DOME. That'll be added in the next release of QuadUI. And you do see the DOME link data here. Okay, so that's that linkage file that allows us to tie the survey data to field overlays and seasonal strategy DOMEs. And again, it allows you to choose the output directory, choose the models that you want to output to, model formats you want to output, and the conversion button at the bottom. Okay, last step, QuadUI troubleshooting. Okay, so what do you do when things go wrong? One of the things you can do is look at the crop model input files. A lot of times the translator will make notes in the input files. Okay, so you can look there to see if something isn't quite the way you thought. You can look at the QuadUI log file. This is a really important file when things fail, that you need to open the QuadUI log file wherever your QuadUI was installed. Okay, so you can open that most recent log file, sort them by date time, pick up the most recent one, and it'll have notes on what DOMEs were applied, what functions were used. If anything failed, you'll see a note there. So that's a very important file to look at. Even if you think everything looked correct, you might want to check the log file to make sure all of your DOME functions were applied correctly. If you're missing some data that you're sure you supplied, make sure that your ACASA variables are correctly identified. The variables must appear in the correct file. For example, if you had a soils information in the weather file, that's not going to work. Check your model outputs for warning and error messages. Both DSAT and APSIM and all the crop models will tell you when things are not as you thought they were. And lastly, even if everything ran correctly through to, you got crop model outputs, check the outputs, make sure they make sense, particularly in the historical run where you've got simulated and observed values that you can compare. So it's really important to get the historical data correct because that forms the basis for all the other analyses. Okay, and AgMIP UI, that really hasn't changed from phase 1. That's run exactly the same way. Okay, so now we move on to part 2. I've covered the historical simulation. Now we go into simulation of multiple years. This is the crop model simulation set 1, current climate, current production system. And what we do here is we introduce a seasonal strategy dome to create a multi-season simulation. Again, you save all the files using ADA to CSV format. Use QuadUI to add this new seasonal strategy. So you're using all the same files that you used for the historical simulation. Now you're adding a seasonal strategy file. You run the models for baseline multi-year conditions and view the error and log reports. This step should be pretty simple. Once you get the historical simulations working correctly, things typically work in the simulation set. And then lastly, you run AgMIP UI to get harmonize the crop model outputs. This is a view of a seasonal strategy dome. You can see up at the top, we've got all the metadata listed in this info section. We specify the year that we want to start the simulation and the number of years of simulation. Here we've got a function that removes all planting dates. And why would we want to do that? The reason is that now we're going to introduce, at least for this particular simulation, they wanted to not use the survey planting dates every year of simulation. They wanted to introduce some planting date rules, okay, where they started the planting window on July 31st, ended the planting window on August 6th, they said that the first day that over 5 days they had 25 millimeters of rainfall, that's the planting date. Okay, so this allows us to vary the planting date every year based on the rainfall patterns. Okay, so the next step is part 3, the hypothetical scenarios. This is the crop model simulation set 2 through 6. This is where we add in the future climate scenarios, we add in wraps, we add in adaptation packages and different combinations. So in the CM2, the future climate current production system, we introduce a batch dome that allows us to loop through all the different climate scenarios using the same inputs that we used for CM1, the current climate current production system. And then for CM3 through CM6, we're going to add combinations of wraps and adaptations using field overlays, seasonal strategy domes, and batch domes. So for all of the simulations, we use the original survey data and the field overlay from that historical simulation without modification. Linkage files are used to apply the multiple field overlays, seasonal strategies, and batch domes. Okay, so here's what the batch domes look like. Okay, again, we have some metadata listed at the top. And what this is telling us at the bottom is that we're going to loop through 5 different climate scenarios. Actually, in this batch dome, we've got 6 climate scenarios because the current climate is included here. We have the ability to specify the CO2. This should be just exactly what is specified in the particular RCP. And what this is going to do is take the same simulation set and just loop through and do it 6 times, changing only the climate ID and the atmospheric CO2 concentration. This is what a linkage file looks like with the batch DOM. Again, we have the EX name. This is each particular farm site has an EX name, and it tells us the field overlay that's applied, the seasonal strategy that's applied. Up at the top, though, what we're specifying is the name of the batch DOM that's used to loop through all of these analyses. Okay, so this is the new feature of the looped simulations with the batch DOM. And we will supply templates for these batch DOMs. Everybody should use pretty much the same ones. They're used for climate analyses. I think some of the teams in phase 2 will look at different GCMs. So you may have to change the template based on the GCMs for your particular region. Okay, so we're recommending that the teams generate these roadmaps for simulations. We've got 6 different simulation sets plus the historical. Okay, so we end up with a lot of files. So a roadmap showing you which files are used for which simulations is a good idea. What this one shows is up at the top, we've got all the different simulation sets, and the first column lists all of the files that are used in the simulations. So you can see that the survey data is used in every simulation set. Similarly, the field overlay for historical conditions is used in every simulation set. We've got weather for current climate that's used in simulation sets 0, 1, 3, and 4. We've got the future weather data sets that are used in simulation sets 2, 5, and 6. And then we've got linkage files. I'll skip down to the linkage files that are used to link together the field overlay and seasonal strategies for each simulation set. And you can see that for the simulation sets where we have adaptation and wraps, we have a lot of different options. Each team will have to decide how they're going to represent those hypothetical management systems. They can do it through a series of field overlays. You can use different seasonal strategies. It just depends on what wraps and what adaptation scenarios you're modeling as to how you're going to represent those hypothetical situations. And then down at the bottom we show the climate batch. So this is a batch DOM that'll loop through the different climate scenarios. Okay, so this is something new. I think it's going to be a big help to have this roadmap in your simulations. And let's see, part 4, we have sensitivity analyses. Again, this is for one farm only. The teams are going to pick a farm from their phase 1 analyses to do the sensitivity. This is mainly to understand how the model responds to these different variables. And this is done through, you use the field overlay seasonal strategy DOMs that were used in the current conditions, current management. That's the crop simulation set 1. And we introduced the batch DOM to allow the repeated simulations for the 32 CTWN and the 99 C3MP scenarios. So this is what the batch DOM looks like for CTWN. At least a part of it. There's actually 32 simulations. We're showing only 18 in this slide. But we've got a new function, a new DOM function called the CTWN function, which allows us to specify the atmospheric CO2 concentration, a change, an offset, or an addition to Tmax and Tmin. It allows us to have a multiplier for rainfall, and it allows us to have a total nitrogen fertilization amount. Okay, so in this way we can have the 32 different CTWN sensitivities all set out in this batch DOM, and you run the batch DOM with your one farm that you're going to be analyzing in detail, and it will loop through these different simulation sets. So here we've got the first 10, for example, are 5 different CO2 concentrations with 2 different nitrogen fertilization, 30 kilograms per hectare and 180 kilograms per hectare. The second set of 6 have changes to Tmax and Tmin, which go together, goes from -2 up to +8. And then we go on through the other sensitivity analyses with rainfall and then nitrogen fertilization on its own. Okay. Similarly, the C3MP has a batch dome that also uses the same CTWN function. The difference here is that we don't specify any nitrogen differences. So these are the 99 different C3MP combinations of CO2, Tmax, Tmin, and rainfall that are used in the standard C3MP analyses. Okay, and last, I believe this is my last slide. We're recommending a directory structure for your crop modeling data, which is going to help you keep track of all these different simulations with a hierarchy for each region. You'll have a crop subfolder, and for each crop subfolder, you'll go through the different analyses, historic, current, future, and note that these 0, 1, 2, 3 up through 6 are the same simulation sets that we laid out in the overall overview of simulation sets. I've got expanded here simulation set 5A. This is assuming that this team had 2 wraps applied, wrap 1 and wrap 2. Not all teams will have 2 wraps, but for wrap 1, we can see that we've got linkage files, seasonal strategy files. They're all going to use the same batch dome to loop through the different climate scenarios. And then there'll be subfolders for DSAT and AppSim, each of which will have its subfolders for each climate scenario. So this is a suggestion. I think it's a good way to organize your data. You can see there's a directory for your cultivar data. These are your calibrated cultivars that are used in all the analyses. There's another folder for your sensitivity analyses and another one to hold your weather, your daily weather files. Okay, so that is all I had to present. Are there any questions on these? We have, I can see we're already at the top of the hour. I apologize for not leaving a lot of time for questions, but I'm willing to stay on and answer questions if you've got them. Everything crystal clear? We'll be covering a lot of this again in when we meet in Victoria Falls. You know, not all of you will be in Victoria Falls, but this webinar is being recorded. It's available for you to share with any of your a group that was not able to attend today.
Cheryl, this is Ken Booty. I'll just comment. I think you did a nice job presenting. This comment about the sensitivity analysis, we'll do mostly that exercise during the Victoria workshop with particularly the maize model and the rice model of both AppSim and DSAT, because we need to understand how they're differing in their sensitivity to CO2, to temperature, and also nitrogen. And we will actually try to do some good discussions after actually running those CTWN simulations there and trying to analyze them and interpret for those who are present at Victoria Falls. This is not meant to be an exercise that everybody goes back home and does a lot of separate things. We need organization actually for what I think should be actually a paper that compares the EPSIM DSET models to each other for those factors.
Okay, thanks, Ken. So that the sensitivity analysis is mostly an exercise in Victoria Falls.
Yeah.
Using phase 1 data.
Mm-hmm.
Okay, very good.
I need to run off, Cheryl, unless somebody else has a question.
Okay, there is a question from Pakistan, but I think I can handle it. So thanks, Ken, for joining in.
Okay.
Okay, so we have a question from Pakistan. If we have 5 strata and 5 GCMs and 2 soil series, then how can we link a single field overlay? Okay, so the field overlays are meant to be, it doesn't have to be one single field overlay. So you could have, if you have 2 different soils, then you could have 2 different field overlay domes, one specific to each soil. You could actually have 3, okay? So you can have one dome that is used on everything, another dome that's specific to soil 1, and another dome specific to soil 2. And so we have a way of piping these domes together such that you can just, they're just applied one over the other. Okay, so we can show you how to do that. We had that capability in phase 1 as well, so it's not difficult. Next question, Alex is asking, CTWN analyses will be done in Victoria Falls, and then we'll follow up as these analyses are key to understanding what climate change will mean to agriculture in each region. Okay, so not really a question, but a comment. That's right. So the CTWN analyses are done first, so you can understand your system. Yep, and we'll be doing those in Victoria Falls. Good. Any other questions? You can feel free to email me if you have specific questions. Most likely, I usually direct those to Meng Zhang, who is just amazing at figuring out any kind of problems with the dome or with the QuadUI translation. So feel free to email me, also Meng Zhang. Any questions about the presentation today, you can also email. I'm not hearing any more or seeing any more in the chat. Okay, Alex, you're welcome, Alex. Yeah, we have come a long way. We're continuing to develop the tools, and we hope to be responsive to the needs of the teams. If there are things, dome functions, for instance, that you would like to see that aren't there already, please let us know. Okay, thanks everyone for tuning in. This it was a lot of material to cover. So again, if you have questions, go ahead and email them to me, and we will meet again for the next webinar in early June. Details to follow in emails. Thank you, everybody.